Thank you for checking out A1 Math, and today we're looking at solving a system of equations by substitution. So let's begin. So here are the steps. Step 1, solve for one variable in one equation. Step 2, substitute the resulting expression into another equation. Step 3, solve that equation to get the value of the variable. Step 4, substitute that value into one of the original equations and solve. And step 5, write the values from step 3 and 4 in an ordered pair x and y. So let's take a look at an example. So first step is to go ahead and solve for a variable. So I'm going to go ahead and take this 2x, negative 2x plus y equals 7 and solve. So I got negative 2x plus y equals 7. And I'm going to add 2x on both sides and get the y by itself. All right, so now that I have it solved for y, what I'm going to do is take this and substitute it in for y in the other equation. So I'm going to write that out just like it is, except I'm going to put parentheses for y. So I got 3x plus y in parentheses here is equal to negative 3. And I'm going to plug in this right here. So I get 2x plus 7. Now I'm going to go ahead and solve here. I'm going to collect like terms. And 2x and 3x is 5x plus 7 is equal to negative 3. Now I'm going to subtract 7 on both sides. And 5x is equal to negative 10. And then I'm going to divide by 5 to get the x by itself. And x is equal to negative 2. So I know what x is. So now I'm going to take that negative 2 for x and plug it into either one of the equations here. And I'm going to go ahead and plug it in. Let's say that the first equation I started with here, negative 2x plus y equals 7. So I'm going to change colors again. I got negative 2x plus y is equal to 7. But x I know now is negative 2. So negative times a negative is positive. 2 times 2 is 4. Now just go ahead and solve for y here and get the actual number. So now I know that my point is negative 2, 3. So step 1, I solve for y. Step 2, I plug that in and got an actual value for x. Step 3, I might have skipped a step there, but the next step here is going to take this and plug it in for x and figure out what y is. And then finally, you write out your x and y as your coordinates. All right, let's take a look at another example. All right, so first step is to solve for y. So I'm going to take this first equation this time and solve for y. So I got x plus y is equal to 4. And I'm going to subtract x on both sides. And y is equal to negative x plus 4. So I know what y is. Y is negative x plus 4. Don't know the value, but I know the expression for it. So now I'm going to take the other equation and plug in that y. So it's going to be negative x minus negative, let me leave that blank right quick, minus y, and I'm going to put y in parentheses, is equal to 6. And I'm going to plug in the y, negative x plus 4. So now I'm going to take that and I'm going to distribute this understood 1 here on both of these. And that's going to give me negative x plus x minus 4 is equal to 6. All right, so now we're going to collect like terms here. And this negative x and positive x cancel out, which is not usual. It's a special case here. So once those cancel out, that's going to leave me with negative 4 is equal to 6. Okay, so when your variables disappear, it's a special situation. It's one or two options. It's either no solution or infinite solutions. Okay, if you get something like this where it's not true, negative 4 does not equal negative 6, then it is no solution. If you was to get something like, let's say, 6 is equal to 6, then that'll be infinite solutions. So just be aware of special cases like that. Okay, so the next thing I'm going to do is show it to you in context. We're going to take a look at a word problem, and you can see how you use substitution to solve that. Okay, now let's take a look at a word problem. Okay, here it has a boat travels at a rate of 18 kilometers per hour from its port. A second boat is 34 kilometers behind the first boat when it starts traveling at the same direction at a rate of 22 kilometers per hour to the same port. Okay, so the first boat has got a 34 kilometer head start, but it's going 18 kilometers per hour. So it's going slower than the other one, which is 22 kilometers per hour. So eventually, the faster boat is going to catch up with the slower one. But when? So it says let D represent the distance the boats are from the port in kilometers, and T represent the time, the amount of time in hours. Okay. The system of equations is D is equal to 18T plus 34, which is the 18T is how fast the first boat is going, but it also has a 34 kilometer head start. It can be used to represent the situation. And yeah, and D equals 22T is the second boat. Okay? So it says how many hours would it take for the second boat to catch up with the first boat? How far would the boats be from their port? Use the substitution method to solve this real world problem. So as you can see, we've got two equations, right? And you've got D is equal to ATT plus 34 right here. So what is D though? I already know what D is. D is 22T. So I'm going to substitute this 22T in for this D. All right, so what I end up with is this equation here. 22T is equal to 18T plus 34. All right, now what I'm going to do is since there's no D involved at all, we'll go ahead and solve for T. So I'm subtract 18T on both sides. That's going to give me 4T is equal to 34. And then you divide by 4, and I'm going to write it over here. T is equal to 8.5. So it's going to take 8.5 hours for the faster boat to catch up with the slower boat. But how many kilometers would that be? So I need to figure out what that d is. So I'm going to take d is equal to 22t and replace the t with 8.5. So the distance where they're at the uh, same distance from the port or to the port or whatever is going to be 187 kilometers. And this t is 8.5 hours. And that is solving a system of equations as far as substitution with a word problem. I want to thank you for checking out A1 Math. Have a nice day. Mhm.